In many tree structures, such as binary search trees, we store elements in the nodes of the tree. Each node represents a single element, and each element is stored within a single node. A tree is slightly different. A tree is a tree structure in which elements are represented by paths in the tree, not by individual nodes. So an entire path represents a tree. Some background information about the word trie. This actually comes from the word retrieval. Tries were proposed as a way of quickly retrieving data. So they were actually originally called trees, as in retrieval. But of course, that would be super confusing if you pronounce T-R-I-E, tree, because we already pronounce T-R-E-E as tree. So they changed this pronunciation now to trie to make it less confusing. So a tree, as I mentioned, it's a tree structure in which elements are represented by paths in the tree. So to help show you this, I'm going to show a binary tree. So just like a binary tree, which has every node has up to 2 children, a binary tree is a tree that is a binary tree. So let's draw an example. Let's say I have let's say I'm going to draw, what tree do I want to draw? Maybe put a node here, I'll put a node here, and I'll put a node here. And it's a binary tree, so I have edges labeled by 0 and edges labeled by 1. Let me just write, this is a binary, oops, that looks ugly, binary tree. So one thing I want to emphasize is that my nodes themselves do not have any contents in them. Actually, let me color a couple other different nodes. Let me color them pink. I'm going to color this one pink, color this one pink. I'm going to get to why I'm coloring them in a bit. But some things that I want to emphasize, in a tree, my nodes are not representing elements. And my nodes in this specific tree aren't even labeled. In a tree, we're labeling the edges. And any given path in my tree represents an element. So this path from the root down this edge, then down this edge, this path represents the string 0, 0. So in this tree, I can label actual elements with this different colored node. Whoops. So this node is pink, meaning that it represents a word. So to list all the words in my, so every word in my tree is the concatenation of all of the edges from the root to one of these word nodes. So in pink, I'm drawing word nodes. So in this example, the words in my tree are 0, which is this path. The root to this node crosses 0, and this is a word node, so that's one of the words. Another word in my tree is 0, 0, because this is also a word node. So this path ends at a word node, so the concatenation of the labels is also a word. Then 1, 0 is also a word, because the concatenation of the labels from the root to this word node is 1, 0. And then here's another word node, which means the concatenation of the labels from the root to this node is also a word. So 1, 1. So my 4 words are 0, which is represented kind of by this node, but really it's the path from the root to this word node. 0, 0, the path from the root to this node. 1, 0, the path from the root to this word node. And 1, 1, the path from the root to this word node. So in each of these examples, each of these words, it's a full path that represents the word.